There we go. So before we start solving area of composite figures, we're going to just do one review problem that you guys have in there. So remember, every time we have a test, we've got lots of review problems from old units. So let's start with that. So Javier has 3/4 carton of drinks. He shared the drinks equally with Feliciano. There are 24 cans of drinks in each carton. How many cans of drinks does Feliciano have? All right, who's got an idea about how to set this up? Gabby, what do you think? Okay, let's make a bar model. Tell me how to draw it. I'll start with a bar. I got it. How many sections should I divide the bar into? Okay. Got 4 sections. Now what? Shade 3 of them. Okay. Okay, got it. Any labels yet? What should I label? Yep, keep going. Okay. You got this.
24 cans each carton.
Well, hold on. It says Javier has 3/4 carton of drinks. So is it 24 cans in each? Did you say each carton or each section?
Section.
Is it though? Alex, you want to help expand on what she's saying?
So basically, you could divide 24 by 4 to find this one out, because then in 1/4 would be 6 cans.
Yep.
1/2 would be 12 cans, and then 3/4 would be 18 cans, and you divide it by 3.
Okay, so hold on just a second. Gotta slow down for me for just a second. All right, so Gabby says Javier has 3/4 of a carton of drinks, right? And then there are 24 cans of drinks in each carton. So imagine one of the big, do you guys go to Costco?
Yes. No.
Who goes to Costco and gets the big things of sparkling water? We do. That's the carton, right? The big thing, and it's got multiple drinks in it. So Javier only has 3/4 of one of those, okay? So the 24 is for the whole 4 quarters. So, so we can set it up like that, and then we know that Javier has 18 drinks, right? It's pretty obvious. Has 8. Well, let's do this with unitary method. Let's do this the right way. All right. So 4 units is 24 drinks. 1 unit would be 6 drinks, and 3 units, which is Javier's amount, would be 18 drinks. But then he shares half of his drinks with Feliciano, which equals 9 drinks. So Feliciano has 9 drinks. Okay, I'm going to show you guys an easier way to do this, okay? Yeah, so here's an alternative way. This is just a fractions problem. And all we need to do is just read it, read the word problem and set it up. So Javier has 3/4 carton of drinks, right? How many drinks are in a carton again? 24. If he shares it equally with Feliciano, he's going to give half of his drinks to Feliciano, right? So really, we're finding half of 3/4 here. Actually, let me set it up with the half in the front. Not that it doesn't matter, because you can multiply in any order, but we're really finding half of 3/4 of 24 drinks. Now you can just go to town with this, right? And just do cross canceling, and then we end up with 9 drinks. That's, oh, no way. We get to cross cancel so much when we have like multiple fractions to deal with. It's so great. All right, so today, all right, everybody have that? Okay, today we're going to talk about the transformation approach. Yesterday we found the area of composite figures using just addition and subtraction, right? So we had a figure, we had part of it shaded, and we're just reviewing. We'll get to your slide in just a second, you guys. And that's kind of how we found the area of these objects. So today what we're going to be doing is we're going to look at an object, and in our mind's eye, we're going to flip that object around. That's the transformation approach. So on your notes, go ahead and copy that red. This approach transforms composite figures into simple figures so that the area can be found more easily. So I'll show you what I mean in just a second. All right, so if we look at the figure on the next slide. Let's pretend we were trying to find, the area of something like this that is in the shaded portion right here. I'm gonna add, do you have, oh, you do have the 70 there, good. So this is 70 meters by 70 meters. Okay, I could look at that and think, wow, that looks a little bit confusing, doesn't it? But in my mind's eye, if I flip-flop those quarter circles around, I can see I just have one semicircle and two quarter circles, which equals how much of a circle? One circle, right? Okay, so let's go ahead and solve for that. What is the radius? If that's square, I have to go back one thing here. What is the radius on this circle, Liam? Yes, great job. Radius is 35 meters. Okay, so let's go ahead and plug that into our formula. I'm going to write it again here. Okay, so remember to always write the formula on that first line of work, and we'll use 22/7. Why am I doing that, guys? Yep, okay, so remember 3 lines of work, 22/7 times 35 times 35. And we can cross cancel with the 7 and the 35 and go ahead and do all of that multiplication. Okay, I see lots of hands going up. Okay. What is it, Austin? 3850 what? I think it's this one's meters, but yes, good job. Did you say meters? Did you? I don't think so. Okay. All right, good job. Okay, so the point of the transformation approach is just one other tech strategy for you guys to use. And if you can visualize a composite figure whose area can be found more readily by just moving the parts or rotating them or reflecting them or whatever, it's going to be much easier and you'll avoid unnecessary calculations. Yes. You're confused on the last one? Tell me why. What's that? No, I didn't say 0.50. It's 3850. You said 0.50? Oh, okay. Well, it's not, but good. You made a decimal error. So, all right. That's all right. So that's, please. All right. Let's go ahead and do the next one together, and then we'll have quite a few Toyos. Okay. So we've got how many quarter circles here?
2.
We have 2. So what is my formula gonna look like here, Mateo?
Oh, 1/2.
And what is my radius? Yeah, nice job. My radius is 4 feet. Yours says 9 on yours? Oh, you know what? I have it in my notes to have you guys cross it off. And use 8 instead. Go ahead and use 8. All right, go ahead and finish that problem off. Charlie? Yep. Read the blurb with the hand. Gabby?
Are we doing 22/7?
No, because we're not using a multiple of 7. So you're going to use 3.14. Alex? Okay, good. All right, Ainsley, can you give me an answer, please? Yes, good job. 25 and 12/100 feet squared. All right, good job, guys. Okay. So here's what I'm going to have you guys do next. I would like to open up your workbooks. we're gonna do a couple things. To start, we're gonna do those other two on exercise 7. So you're working on numbers 3 and 4. And you may work with your table partner. We are not moving around the room. Austin, you can move up here and work with Maikoi. Everybody else, I think already has somebody sitting next to them. Okay? And that's what we're gonna do. Go ahead and take about 5 to 10 minutes to do that. Oh, okay. All right, Maddie, you wanna give us a hint?
Can we ask right? No.
Well, I don't want you guys to give the answer quite yet.
Okay.
Tell me what your first step was before you could.
The area of that, and then
Like the whole circle?
Yeah, like the whole house. Slides on the bottom are going through it.
Yeah.
We divided it 42 by 6, so the radius on the smaller one was 7.
Okay, so the radius, so you divided 42 by 6, and you found that the radius here would be 7. And then the radius of the large circle, of course, is half of 42. So you use 21 for that? Okay. All right, good. Keep going, guys. Finish this one off, all right? Maddie and Nora. Okay, so I assume you substituted in 1/2 times 22 over 7 times 21 times 21. And then you probably did some cross canceling, right? Because that makes life easier. And then you ended up with 33 times 21. And what was the area of the large circle?
693 inches.
Okay, inches?
Yeah.
Squared.
Oh.
Inches squared. Oh, you said inches squared? Oh, I just didn't hear you. Okay, I'm sorry. And then the area of the small circle, you probably cross canceled there as well. And what did you end up for that one?
77.
Okay. And then what was the final step that you needed to do?
Subtract 77 from 693.
Nice job. So 693 minus 77, and you ended up with what for the total area? Yes, good job. 616 square inches. Okay, there's that one. All right, keep going on number 4. Keep going on number 4, guys. All right, so for this one, let's think through how to find the radius. First of all, let's use transformation. How many circles do I have here of these small circles? I have what, Gabby? I have one small circle, right? And I have one large circle, but then I've got some triangles. All right, what is the radius of the large circle? I'm gonna label that radius large. What's the radius of the large circle, you guys? It's given to you. What is it? 10. All right, how about the radius of the small circle, guys? What's the radius? Yeah, that's radius of large circle. Radius of the small circle. What do you think, Charlie?
Well, since the radius of the big circle is 10,
Uh-huh,
and half the circle's the diameter of that is 10,
uh-huh.
then it's 5.
Then it's 5. Good job. Since the radius of the big circle is 10 right here, that means this measurement is also 10, right? Because that's a radius. So that's the diameter of the small circle. So the radius of the small circle is 5. Okay. So we're looking for 3 things here. Yeah, Maddie, go ahead.
The triangle.
Yep. Yep, we need to find the area of the triangle, the area of the big circle, and the area of the small circles. How do we find the area of a triangle? What's the formula? Alex?
Base times height.
No? Liam? 1/2 base times height. Okay. All right, so if we find all of those areas, we found the area of the big circle, the area of the small circles, and the area of the triangle. What are we going to do as our last step? Let's plan this strategy out. What are we going to do? Because we're trying to find the area of the shaded part. So what would that look like? Go ahead, Alex.
Just basically add the 2 half circles to, no, the 2 semicircles,
Uh-huh.
and then you'd also add the triangles area.
Yep.
And then you subtract from the big
From,
circle.
yes, exactly. So we're going to subtract the 2 semicircles plus the triangle from the big circle. All right. Okay. Let's see if you can beat me. I'm just kidding. You don't need to beat me because I already know what I'm doing. It's kind of silly. I'm not cheating. I've already done all these.
3.1.
What's the base on the triangle, you guys? If the height is 10, what's the base?
10.
20.
20. 20.
How is that?
This is the height. Well, you know what? It doesn't really matter.
Oh,
It's,
'cause the one
yeah.
big triangle.
So, yeah, so we've got 10 and 10, which is 20, and then 10 right here, which is the height. So. All right, who has the area of the large circle? Alex, what do you have for that? Okay, 314 meters squared. Great. We had 3.14 times 10 times 10. That one was an easy peasy one. How about the area of the small circle? What do we have for that one, guys? Kala? Nice job, 78.5 meters squared. How about the area of the triangle? Also easy because we could cross cancel there. What's the area of the triangle? Kayla, do you have that? Good. The area of the triangle is 100. All right, so we're gonna take 314 and we're gonna subtract 178.5 meters squared from it. And what are we gonna get for our final answer? Kala? It is. Way to go. 135.5 meters squared. Okay, here's what I want you guys to do next. Go to exercise 8 and find one problem that you would like to work on for the next couple minutes. These are all extremely challenging. Do it. Go for it. You got it.
Wait.
Go ahead and just pick one problem, and that's what you guys are gonna do for 5 minutes.
Easiest thing ever.